How's it going, guys? I'm going to go ahead and work out some more guided practice on ellipses. We're going to see a couple things here. Maybe clear up some, I don't know, any misconceptions you might have. But let's do this. We're just going to graph these and identify the vertices, co-vertices, the foci, the major axis length and the minor axis length. And this other thing I'm adding here is an afterthought, is eccentricity. So we're going to learn about all these things, or just go over all of them and just kind of get a look at how that works. Okay, so I'm going to graph this, and the center I can see, the standard form equation for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So what tends to happen is, well, the center, it's not what tends to happen, it's what always happens. The center is hk. But since I'm not subtracting anything for x or y right here, then the h and k is 0. So basically it means that the center of the ellipse is right here at 0, which is nice. Okay. The bigger of the two values is actually your a squared for the ellipse, and a squared in this case will be 49. Okay. So that means the square root of a would equal 7. The smaller value would be the b squared. So b squared in this case is 25. And the square root of that would be 5. So this is the length, or half the length of your major axis. So what this tells me, since this is 7 and the a squared is underneath x, we're going to go from the middle, from the center, 7 to the right and 7 to the left. So I'll go 1, 2, 3, 4, 5, 6, 7 and put a point, and go over here at -7 and put a point. So 7 this way. So this length right here, we're calling that 7. Okay. And of course, if I were to ask you for the length of the major axis, which is what I do right here, this would be 7 and 7. So that total major axis length, which is the longest axis, that's what major axis means, is going to be 14 for this answer. So this will be 14. Okay. And this right here, b, which is 5, that's going to be, since b squared is underneath y, we're going to go 5 up and 5 down. So we're going to go up 1, 2, 3, 4, 5, and down 5. 1, 2, 3, 4, 5. So this right here is the length of b. This will be 5 from the center, and we'll go 5 down this way. So this entire thing right here is called your minor axis, which is going to be double this. So this is going to be 5 and 5, so the length of the minor axis will be 10. So basically the major axis length is 2a and the minor axis length is 2 times b, just to show you how that works. Now we can actually draw the ellipse if we wish. We're basically trying to connect all of these. So let's actually talk about the components first before I start drawing. These points on the end of the major axis are called vertices, right here and right here. The points on the end of the minor axis are called co-vertices, right here and right here. So they're going to ask you for these points, right? The vertices and the co-vertices. But I'm going to draw this really quick. And here. Okie doke. So that's really nice. All right, so we have that. That's about as best as I can draw the ellipse, which is an oval shape, by the way. And let's see, better colors. Wish I had something really easy to see, but I don't. Okay, so now we're going to find the foci. Foci basically determine the shape of the ellipse. The closer the foci, there are two random points here, the closer they are to the center, the more this will look like a circle. The further away from the center, the more it looks like an oval shape that's not a circle. And there's a measure for how circular it actually is, and this is referred to as eccentricity. Okay, and we'll talk about that. This is sort of an afterthought for me, but in other classes, particularly at the UT on-ramps, they will talk about eccentricities, so I would go ahead and cover it in this class as well, just so you're not left out, okay? Because, I mean, it's a minor thing to me, but just in case it comes up later on in your academic career, you'll be exposed to it. So we have this. Now, how this works is we can find the coordinates of the foci, or foci, or however it's called, right? I've heard it called different things, but we'll call it foci. Okay, so foci Let's see. Don't call it focuses though. That's wrong. I've heard people call it that too, and that's not true either. So there's a point called the focus and another point called the focus. There's two of them, but plural they're called foci. So the coordinates of the foci can be found, the distance from the center to the foci, I should say, is c. And we know that c squared will equal a squared minus b squared always. And the reason is because a is always larger than b. It's always the larger of these two values, okay? So this will actually be my 49 minus 25. I'm subtracting a squared and b squared. And this is basically all I'm doing, okay? And this will be 24. Okay, so the square root of that will be, well, root 24, which we could call 2 root 6 if you want. Either way, that's fine. I'll actually just call it root 24, but you can call it 2 root 6 if you wanted to. And the foci are always located on the major axis, which is the longer of the two. So we're going left and right. It's on the x-axis here is the major axis. So from the center, we're just going to go root 24 to the right and root 24 to the left, which is just a hair underneath 5. So it's going to be like right here, and root 24 to the left, which is just underneath 5, is about right there. So these are referred to as foci. Individually, they're called a focus. Okay, I really should just call these a focus and a focus because they're both focus. Okay, so each one of them is a focus. Together, they're called foci. Okay, so how does this focus thing work? Well, what happens is if I were to put a string right there and right there, and I wish I had a different color. We have a bunch of colors, it's none of them are easy to see. Doesn't matter what I pick. Yellows are really hard to see. Ooh, no. Let's try that one. And I put a point here and I put a string and I just nailed it right there and right there for those of you who watched that video. The length of this entire string is the same as the length of the major axis. This is always true. But what happens is if I were to pull a pin through this up into the string and pull it taut, I can actually draw around these two foci and it will actually create the shape of this ellipse. So that's kind of what it's used for, is for drawing that. But the shape of the ellipse is actually determined by each one of these foci. So, but they're asking you just simply for the coordinates. So that's a lot of explanation for the graph, but let's just answer all these questions. So the vertices will get right here, this coordinate right here, and this coordinate right here. So what we're going to do is just add a to h, and h is going to be 0, so it's going to be h, or add and subtract it, so it's going to be h minus a and h plus a comma k. So in this case, the vertices are -7 and 0 and 7 and 0. It's not going to be a big deal. The co-vertices, we're going to go 5 up and 5 down from center, so this is going to be 0, -5, and 0, 5. Okay, so we got those down. Vertices, co-vertices. The foci, we're just adding and subtracting root 24 from the center on the x only because it's on the major axis. So it's going to be negative root 24. I'll leave it, comma 0, and root 24, comma 0. Okie doke. All right, so we did that. Vertices, co-vertices, foci, length of the major axis. I'll just call it major and minor. Major length, we'll call it. So the major length is going to be 2 times a, which is 2 times 7. So we're going to call that 14. And the minor is 2 times 5. So we'll call that 10. And then the last thing we'll talk about is the eccentricity. Now that thing is basically telling you, it's a ratio that basically tells you how close the thing is, the ellipse is, to being a circle. And eccentricity is going to be equal to c over a. And basically, we'll call this value e, is what we'll call this eccentricity. So e is always in between 0 and 1. Oh, can't equal. Somewhere between here and here, okay? For a non-circle ellipse. Okay, so what's going to happen though is if I were to move this focus closer to the center, and the other one will follow suit and do the same thing. The closer, well, the distance here from the focus to the center is called C. So if I move it closer, C becomes smaller, right? It means it gets closer, this entire thing gets closer to 0. So the closer to 0 you are, the closer you are to having a perfect circle. And the closer you are to getting to 1 means you're moving further away, the less you are likely to have a circle, or call it no circle. So this is just some sort of a ratio they use to determine just how close to being a circle or how circular the ellipse is. It's just a measure of that. It's not something I really spend a lot of time on or harp on, and I'm just giving you the ratio of how to find it, okay? And that's how that works. So this C is the distance from the center to the focus, and A is the distance from the center to the vertex. So if you move the focus closer to the center, the top value here, C, becomes closer to 0, and the eccentricity will approach 0. If you move it further away, you can't go past the value of A. C can't actually reach A. So C gets closer and closer to A if you move it outward, and that means this ratio gets closer to being 1, which means you're getting closer to not having a circle, or getting further away from having a circle, I should say. So that's all that works. That's basically all of the anatomy of an ellipse, okay? All that long-winded explanation. So we're just going to go a little faster here, and hopefully you can just keep up, and we're just going to do the same thing. The only thing different about this one is now your a squared is underneath y, which means your major axis will be up and down from center instead of left and right. So here's what I got. My center is 0, 0 again. You should always identify that first, really. 0, 0. And now I have my a squared is being 16, which is the bigger of the two, so a will equal 4, the square root of 16. So b squared is going to equal 9, so b will equal 3. So my center is here, 0, 0. And I'm going to go 4 up and 4 down because the major axis is along the y-axis. It's underneath y, so we go up and down only. 1, 2, 3, 4, and down 1, 2, 3, 4. On the minor axis, we will go 3 to the right and 3 to the left. The smaller numbers are underneath x, so we're going to go the square root of this value left and right of the center. So that's how that's going to work. So you're going to get something that looks like this when you draw it. Okay. There you go. So let's find all the answers here. So here we have the vertices. So we'll go ahead and find that. From 0, 0, we're going 4 up and 4 down. So we're going to have negative 4 and 0. Ooh, gosh. Not negative 4, 0. We're changing the y, not the x. Always do that. 0, negative 4, I meant to say. And 0, 4. Okay? Those are the coordinates of the vertices. Now the co-vertices are right here and right here. Co-vertices. Okay, co-vertices. Now those are going to be, looks like negative 3 and 0 and 3 and 0. I sorry, 3, 0. Yeah, that's right. Okay. And the major minor, I'll just call it major minor length. Your major length is going to be, well, this is 4 and this is also 4, so the total distance of the major axis is 8, or double what a is, and the length of the minor axis will be double what b is, which will be 6, because we're going 3 this way and 3 this way. So that's kind of how that works. Boom, 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 boom. What else do we're missing? The foci. Let's go ahead and do the foci. So the foci, we're determining the foci by saying c squared is equal to a squared minus b squared. It's the way it always is for the ellipse. So now I have 16 minus 9. 16 minus 9, which is 7. So c will equal root 7. That's the distance from the center to the focus, to each focus. Okay, there's 2 of them, plural foci. Okay, so here's what I have. The foci are kind of, let's change this color to, I usually pick a tan or a gold or something. Root 7, let's see, okay, well, that's somewhere between 2 and 3, really, so, I don't know, 1, 2, 3, it's like, I don't know, right here, 1, 2, 3, let's just make it up, okay, so like right there and right there, and that's kind of where they would be located, but we're just going left, or sorry, we're going to go, ooh, okay, so the foci, they're going to be located on the major axis, which is the y, and root 7 is a little less than, well, it's between 2 and 3. So we're going to go up about 2 and change between 2 and 3, and down between 2 and 3. So they're about right there-ish, okay? And that's where they're located. So since we're moving up and down, we're only going to change the y value of the center, and we're going to leave the x value the same. So this will be 0, negative root 7. And the other one will be 0, root 7. Root 7. Now we're talking about this thing called eccentricity. I'll just call it E. And that's going to be C over A. Which is going to be root 7 over 4. So if you were to ask, what's the eccentricity of this ellipse? That's the answer. It's C over A. And basically, the closer this value is to 1, the further away is to being further it is away from being a circle, and the closer it is to 0, the closer it is to being a circle. That's really the only interpretation you're going to get out of that. So, like I said, this is one of those things that that they sort of briefly cover, and I'm just going to go ahead and tell you what it is. Okay. Here's where it gets a little more challenging, because now they're giving me the equations in general form. So we're going to convert these out of here by completing squares. So what I have to do here is group my x's and my y's, and that's not a whole lot of work there. It's actually going to be pretty easy because there's only one term for each, okay? So when that happens, this is really nice, because all we're going to do now is move the constant, which is this 196, over and make it positive. And then what we're going to do is your standard form equation is always equal to 1, so we're just going to divide everything by 196. That's all that's going to happen. And this will fix itself, as it turns out. So I'm converting it to a standard form. This is going to give me a 1, which is exactly what I want. So 4 over 196, I don't know what that is. Let's see. Off the top of my head, 1 out of 49. That's really great. So this is going to be 4 over 196 is 1 over 49, so this is y squared over 49. And that means that 49 over 196 is going to be 1/4. So this is actually going to be x squared over 4, which is really nice. So this is my standard form equation that I have here. So now this is really easy to graph, because now I know that my b squared this time is 4, which is the smaller of the two, and my a squared is 49. So b is going to equal 2, a is going to equal 7. The center is still going to be 0, 0. So here we are. Major axis is what? This bigger number is underneath y, so it's along the y-axis. We're going to go up 7. We're going to go down 7. Minor axis is, well, the length from the center is 2 to the covertex, so we're going to go 2 to the right, 2 to the left. So this is actually kind of a narrow looking ellipse, rather, like this, kind of like a canoe shape. And that's what you have here. So that's what this graph actually looks like, all quickly done just from this equation. And now we can find stuff. So let's find the vertices, co-vertices, the foci, and let's go ahead and find the foci this way. Foci is going to be given by c squared is equal to a squared minus b squared. As we've done, this is going to be 49 minus 4. And this, c squared, is going to equal root, it's going to equal 45. We'll just take the square root of c squared is going to equal root 45, we'll call that. Okay, root 45, you could write this as being 9 times 5, or you could write this as 3 root 5 if you wanted to. Okay, or you can just leave it as root 45. I actually just don't mind either way, honestly. Okay, but all you need to know really is that it's somewhere between 6 and 7 is the most important thing, and it's on the y-axis. So we're going to go up about a little bit bigger than 6 and 7, somewhere. I'm just going to put it in the middle since I'm not quite sure. and these hash marks are so close together it doesn't make a lot of difference anyway. Was that a 4? Oops, I did it wrong. Can't read the old grid here. We need to go above 6, and okay, so it's almost near the end. Good grief. Somewhere between 6 and 7, close to the actual vertices, but that's where they are. That's why this thing is actually so narrow, is because the vertices, I mean the foci, are so far away from the center. They're actually close to the vertex of each side. So that's why it makes this stretched out shape. The closer you move the foci to the center, the more circular it looks. This is not a circle at all, obviously, because the foci are quite far away from the center. Okay, just a little food for thought. So the vertices, okay. So this point and this point, very easy. This is going to be 0, -7, and 0, 7. The co-vertices are here and here, so it's going to be -2, 0, and 2, 0. The foci are on the major axis, which is on the y, so this is going to be 0 and -√45. I'll leave it as √45. You could call it 3√5 if you want, but I'm not going to. And this will be 0, positive √45. Okay. The length of the minor, go ahead and do that, will be 2 times b, which will be 4. The major will be 2 times a, which will be 14. And the eccentricity, we should call it, is going to be c over a. And c is going to be √45, or 3√5 if you want. Now we could call it 3√5 over a, which is 7. So you can leave it like that if you want to, if they were asked for it. Or you could call it √45 over 7. Same thing. But that's basically all your answers for this, including the graph. So this is how you do these questions. It's, once you get the hang of it, it's no big deal. And you really should print this. I'm posting this worksheet, so you should print this and actually practice this yourself. But, hey, that's up to you. Okay, so we have this. We're going to convert this to standard form. This is the same process before. We don't have to do a whole lot of computing of squares because there's no x or y terms by themselves. So we're just going to move that 400 over to the right, make it positive, and then we'll just divide everything by 400 now. And that's all you're going to do. It's the same process before. These are nice, actually easy problems compared to some others you could see. So, and what is that? Let's do 16. I imagine that 25 over 400 is going to be 16. And there it is, yep. So this is going to be x squared over 25. And this is a square, by the way. And this is going to be y squared over, this is going to be y squared over 16. This is going to equal 1. And that's what will happen very predictably. Alright, so my larger of the two values is 25, so that's my a squared. And my b squared is 16. Okay, cool. So a is going to equal 5, and b is going to equal 4. And the center is again 0, 0. Because we're not subtracting anything from x or h inside that square. So here's, do a color we can see. This is my center, 0, 0. We're going to go left and right by 5 for your major axis. Up and down by 4 for the minor axis. And then you'll get something that looks like this when you draw it closer to being a circle. So your eccentricity will be closer to 0 here than the previous answer for sure. And then we're just going to kind of see what we get. So the one thing we have to worry about now is the foci. It's the only tricky part that's left. So it's going to be c squared equals a squared minus b squared. And this will be, what do we have? This will be 25 minus 16, which is nice because that's going to be 9. Cool. So c will equal 3. And they're on the major axis, so we're going to go 3 to the right, 3 to the left, and that is actually where they are located, the foci, each one of them. Okay, and that's really easy to do. So now we can just write everything out. So the vertices, which are here and here, are going to be -5 and 0, and 5 and 0, 5 and 0. And the covertices are going to be 0, -4, and 0, 4. The foci are going to be -3, 0, and 3, 0. The length of your minor axis will be double what B is, so it'll be 8. Your major will be double what A is, so it'll be 10. And your eccentricity will be C over A, which is 3 over 5. Okay, cool. And that's it. Good times. Very good. These are the last 3 questions. Here I'm just going to make you write the standard form of the equation instead of finding all the little pieces to the ellipse. So if I could just give you some pieces, and then you're going to use that information, whatever they give you, and try to figure out the equation in standard form, which will be, you know, kind of your x squared, or I should really write it correctly, is x minus h all squared over presumably a squared, although you could switch the a squared and the b squared in this equation, depending on whichever is bigger, equals 1. Okay, so my vertices, as you can see, what I'm changing to find my vertices is my x value. So that means my major axis is along the x-axis, which means a squared is underneath x. Okay, that's where the vertices are on the end of the major axis. The covertices, we're changing the y value, so that means b squared is smaller, because the b squared underneath y, we're going to go up and down to find the covertices. The ends of the minor axis are the covertices. So essentially, this is really good though, because I can tell that the center here is going to be 0, because this is symmetrical. Notice that the y value here is 0 and the x value here is 0. So essentially what you're looking at, if I were to make a quick sketch of this, is you have a center here at 0, and we're going to go 10 this way, and 10 this way, and 5 down, and 5 up. And that's what's happening. These are your covertices, these are your vertices, and it's centered at 0. This thing would look kind of like this if you were to draw it. Okay, this would be 5, 5, 10, and 10, this distance, and this distance, and so forth. Okay, so fair enough. So here's what I'm going to tell you. This distance here, 10, is a. Okay, it's a. So that means a squared was 100. A equals 10, b equals 5, a squared is 100, b squared is 25. H and k, in this case, is 0, 0. So this is an easy equation to write. Your answer will be x squared over 100 plus y squared over 25 would equal 1. This is always equal to 1, and this is your answer. This is actually what this would give you if you were to draw it. Okay? Very simple, actually. That's in your standard form. Okay. This one's a little trickier, which is fun. What they're telling me is that the focus, each focus, the foci, are along the y-axis, which means that the major axis is a y-axis. So that means that a squared is underneath y this time. And same thing with the vertices, we're changing this and changing this. Okay, only the y, which means the major axis is still on the y-axis. So what's happening here is, here's what how I'm going to determine this. The distance of C is 5. Okay, 5 to the right, 5 to the left, or whatever. And what I know is that C squared is equal to a squared minus b squared. But because the vertices are changing the y value only, it means that this a squared is underneath y. And I know that a is going to equal 13. Because this is symmetrical. We're just going to take the difference between these and cut it in half, and it'll give me what? It'll give me 0. So the deal is what I have here is I have 5 squared is equal to 13 squared minus b squared. So 25 is equal to 169 minus b squared. That means b squared is 169 minus 25, which is 144. So that means that b is equal to 12, as it turns out. How about that? So that means that b squared is 144. So I'm just making the equation. I'm not trying to draw it, but let's draw it anyway, just to show you. I'm centered still at 0, 0. My vertices are 13 and negative 13. So let's say this is negative 13 and this is 13. Okay, and right here I have 12 for my minor, so it's not quite as far. We'll call this 12, 0, and right here we'll call this negative 12, 0. And here's technically what this drawing would look like. Not quite circular, but not far from it. And right here, if I go 5 up and 5 down, relatively speaking, this will be my foci right here. Each one of them is called a focus, okay? So this is kind of what this drawing is doing, but here's what I'm trying to tell you. Here's the most important thing to get out of this little sketch, even though you're not asked to draw it. This distance here is c, and that distance is 5. And the distance here, all the way to the top, is called a on the major axis, and the distance here is called b, right here. So this squared minus this squared will equal this little piece squared. This is kind of how this always works, okay? So that's how I was able to draw this. So actually, let's make the equation. Let's get the answer. We have x squared. The longer axis is going to be the y, so the smaller number will be underneath the x, and that's going to be basically, when I found the value of b, it's 12 squared, so it's going to be 144. That's what b squared is, right? And it's going to be plus y squared over a squared, which I'm telling you a squared is 169. It's going to be 13 squared. Okay, I told you a squared is 13 squared. That's 169, and this will equal 1. This is actually the equation you're looking for this. That makes sense. Okay, final question. Pretty straightforward. Now we're going to have the foci. We're changing the y value, so we're going to leave the x value of the center. So we know this x value is centered. Center of has an x value of 0. Ugh. The minor axis, we're going to only change the x value and leave the y value of the center. So the center for this will be 0, 0, which is pretty standard for the rest of these questions. So here's what I'm going to do here. For the foci, I'm going to say that the distance here to the foci from the center is 12. So we're going to say that c squared is going to equal a squared minus b squared. Now, because the endpoints of the minor axis, which are also called covertices, is the same thing as the endpoints of the minor axis, are 5 away from the center in either direction, we know that b will equal 5, which means b squared is equal to 25. So what I really have here is this is 12 squared is equal to a squared minus 5 squared. So that means a squared is going to equal 12 squared plus 5 squared, which is 144 plus 25, which is 169. So a is going to equal 13, and that's going to be along the y-axis because the minors are changing the x, which means the majors will change the y from the center. So here's your center. I'm going to go up to 13, and this distance here is called a, which is 13. Okay, and we're going to do the same thing the other way. So let's draw this a little longer, keep it symmetrical as much as possible, and we'll make this about right here, I guess. And this distance is also going to be a, which is 13. So this is your major axis. The minor axis are at -5 and 5. So we're going to be here and here. And this distance is called B, and this one as well. Now we have this thing called a focus on both directions, so it's going to be one about here at -12 and the other one up here at +12. And those are your foci. And that distance here along the major axis, which is the y-axis here, this distance here will be called C. And same thing for this one. Oops. Let's go like that. So this will be called C as well. So the deal is C squared, that distance to each focus, is equal to A squared minus B squared. It's the major axis, half of it, minus half of the minor axis, both of them squared. Kind of how that works. So this is what we're going to do. We're going to connect this point, connect this point, connect this point, connect this point if we were to draw such a thing. And it would look like this. Of course, you're not asked to draw this. You're not asked to do any of this for this question. All you're asked to do is to make the equation. So center is at 0. X squared will have the smaller of the axis. So if I say B is 5, that means B squared is 25. It's going to be X squared over 25 plus Y squared. The square of 13 is 169. And this will equal 1. And this will be your equation for this answer. Okay? Hopefully that makes sense. We're just piecing it together, but you have to understand the relationship between A, B, and C, and then you can easily do this. Okay? Appreciate you watching.